Let us solve the exercise number 1 in the part B of data structure lab. In this exercise, we are supposed to sort the given list using merge sort technique. Before we venture into this merge sort technique, let us quickly recall what is merge sort technique. In the merge sort, you are given a array that contains a list of elements. They are in the unsorted order, and you are supposed to sort them using the merge sort. What are the techniques that we are following? The first technique is to split the array into smaller subgroup. So if you look at this array, the minimum index of this array is 0 and the maximum index of this array is 8. Don't worry about the values there. I am only interested in the array index value here. So this is the, let me just show it here. This is the minimum index and this will be the maximum index. Now you try to find the middle value, that is the mid value. So you know very well mid of this will be 4 here. So you split the array into two halves. The first half will be this part and the second half will be this part. Now the given problem was a single array containing all the elements. What you have done is you have subdivided into subgroups or subproblem. Now take this one as the problem. Try to solve this one. Again, take this as the separate problem and solve it. And when I say solve it, sort it in the ascending order of this particular subset. Proceed this again. So in other words, you have the given array here. You have split it into two halves. Try to sort the first half and try to sort the second half. Now take the first half. Let me take the first half. Again, try to find the minimum here. So minimum will be 0 itself. The maximum in this case for this subset will be 4. Try to find the middle of this. So let me assume that the middle is here. Now what you are supposed to do is you are supposed to sort this array. Take this subset and take this subset and then solve these subsets. So take this one as one group and take this one as one other set and then solve it. Now how do you solve this one? So again the same story. Take this one as the original array. So take this part as the original array, and for this array this will be the minimum, this will be the maximum, and this will be the middle one. Okay. Now what you are going to do? Same thing. Split this array into smaller subgroup. This is one subset and this is the other set. Take this one as the new problem. For this will be the minimum. This let me just drag it here. This will be the minimum. This will be the maximum. Remember, I am only interested in the index value, and the middle value of this will be here itself. What about the other set over here? For this set, you will notice that this is the minimum, that itself is the maximum. Remember, I'm talking about, again, let me remind you, I'm talking about the index value. Don't worry about the values, the actual values. We are not interested in the actual values as of now. We are only interested in the indexes of this array, and this itself will be the middle value if you try to go here. But this is violating the condition. What is the meaning of saying violating the condition? When I say minimum and maximum, generally what I assume is, let me take this one here. Okay. So when I say minimum and when I say maximum, so I generally assume that, let me just keep it here. I generally assume that the value, that whatever value that minimum is there, this is smaller than the maximum. So you are going to split the array into subgroup only when minimum value is smaller than the maximum value. So let me highlight this one more time. So in the original array that was given to us, this is the minimum. What is minimum? Value is 0. What is maximum? The value is 8. So in this case, you notice that the minimum is 0 and the maximum is 8. So that means to say that the value of minimum is smaller than maximum. Let us look at the other array, the subset that we have taken. This is the minimum, and let me just close that. And this will be the maximum. 4 is the maximum. Let us look at the next split that we have done. The minimum is 0 and the maximum is 2. Okay. So in all these cases, what you notice is the minimum value is smaller than the maximum value. So when such a thing happens, we are going to split it. But when it comes to this particular array, that is in this case, both minimum and maximum are pointing to the same location, that is 2. So in this case, there is no more, you cannot split. In other words, you cannot split this one into subgroup anymore because there is only one element left over. So we are going to stop the splitting part. So the first part of the merge sort is take the given array, split it into two halves, and repeat this process. Take the first half, split it into two halves. Okay. Again, repeat this. Take this one, split it into two halves. Keep on doing it until you get a situation wherein the minimum is not less than maximum. When such a thing happens, you have to actually sort. The sorting starts from that point onwards. So in the initial stage, what you're doing is take the array, split it into two halves, and recursively do the same thing. Take the first half of the array, split it into two halves. Okay? Recursively take again the first half and the second half. You have to do it for all of the partitions. Take this one, split it into two halves. You will keep on doing it until, as in other words, as long as minimum is less than maximum. So how do you then sort the array? So let's take the other half here. So this was the first half that we had. This was the second half because I cannot move this pointer beyond this level. So it is a bit difficult challenge for me. So for this particular array, you have the minimum for this partition. This is the minimum. Minimum is 5 and maximum is 8. Okay. And the middle value, roughly, let me just take it here. So middle value will be 8 here. So this is this middle value will be 6 here. Now split one part here, split the other part here. So what you get now is minimum is 5 and maximum is 6 here. Same thing for the second half here. So this is not the maximum, this is the maximum. Okay. Then for the second half here, minimum will be this 7 and maximum will be 8. So this is for the, so this one is for this part and this one is for this part. Okay. Now again, minimum is less than maximum. You can further split it. So now split this one into one more set. So what you have here is this is the middle value, you know very well. So you get the middle here. Okay. So split this one into one half, the other one into other half. In this case, what you notice is both the minimum and the maximum are pointing to the same location, that is 7. So both minimum and maximum are 7. So this is violating. So when such a thing happens, you stop the splitting. Same thing, if you look at this one, the other set that we have taken. So this is one set. This is the one partition. The other one is the other partition. For the other partition also, you notice that both the minimum and maximum are pointing to 8. So this is again violation, okay, because minimum and maximum are pointing to the same location. You stop the splitting, so you won't split it further. Now you start coming back. So from this step, you come back and you try to sort the array. So once you reach the end point where you cannot further split the array, you come back. Now when you come back, what you are supposed to do? So you notice that 31 is larger and 12 is smaller, so they are not in the sorted order. You bring them back in the sorted order. So that means to say that when you come back, put the 12 at the proper location. So 12 must come here and the 31 must come at this point. So this is what you are supposed to do. So when you are coming back, you merge them back in proper order. So this is one array, this is the other array, maybe sub array. Merge them in such a way that when you merge them, they are in the sorted order. So 12 must come here and 31 must come on the other side. Okay. So how do you do that thing? Remember, you cannot simply take this 12 and put it here. It is not possible. Suppose if you try to do this thing, what is going to happen? See, even though I have shown this one as a separate two boxes here or two elements over here, this is actually the same array. So it is the same array that I am showing you, same value I am showing you. So suppose if you try to do it on the same array, what will happen is the 12 will override 31. In that case, what will happen is this 31 is gone altogether. So this 31 which was here, this is the element at A7, that will be permanently overwritten by 12 and you don't know what was the value. After this has written, 12 is written over here, you don't know what is the value of what was the old value of A7. So you cannot do it on the same array. So what is that you are then supposed to do it? You take a temporary array, separate array, you take a temporary array and then do the merging and finally write the merged array back to the original array. So you don't do it on the original array, you do it in a temporary array. So let's assume that you have a temporary array. I'm going to just call it as a temp. Okay. In this temporary array, you bring the a, that is a8 here, that is 12 first and 31 next. So you are not disturbing the original array. Original array is as properly it is there. Now once this is sorted, now you know that this is sorted. Now bring it back or overwrite the original array. So in other words, override this with 31 with the 12 and override 12 with 31. So you bring this 31 here, okay, and you bring this you bring the 12 here and you bring this 31 here. Same way, when you are going to do the merging for the other set here, so this was the original array, you splitted it into two half and you splitted this one into two half. Now similarly you have to split this into, you have splitted it into two half. Now you notice that both the minimum and maximum are pointing to the same location. You can't further subdivide it. Again, you can't further subdivide it. Now you bring it back to the original array. How do you do it? Again, the same story. You create a temporary array. You know that 8 is smaller than 15. So these values should be interchanged. So what you're going to do is you bring this 8 here and then you bring the 15 here. Okay, so this is how you are going to do that sorting. So once you have done the sorting, you bring them back to the original array and override the original array. Now once this is done, you have to do the same thing. So this part is done now. Okay, this part is done. Now you merge these two. Now again go back, you merge them back to this one. So how do you merge it? Again take the temporary array. Among these two, find which is smaller. So all this among both of them, 8 is the smallest one. So you bring this 8 here, bring this 8 here, and then again check among them which is the smaller. So 12 is the smaller. You add that 12 over here. Again, among these two, which is the smaller, 15 is smaller. You write 15 here. And among these two, 31 is the smaller. You do this. So now this is sorted. Once you get this temporary sorted array, you override the original array. So you bring it back to the original array. Let me just bring it over here and you do it. Okay. So this is how you are going to do the splitter. So let's try to write the algorithm for this one. So what is that we were doing? So we were first splitting it into smaller subset or smaller partitions until it is not possible for us to split it further. Once it is not possible to split it further, we are going to merge them back. So let's write the story of merging the element. So I'm going to go to the code block here. I will quickly create a new file here. So I'm going to go to this one and I will select C and C++ source. Let me click go and let me click next, and let me just write the word as merge here, and then split. You can give any name here. As usual, I need stdio.h. So I'm going to do this one, stdio.h, done. And let me take the array itself. So if you want, you can take the array. Now I'm going to just write the function first for merging them back. So let's write the function for merging. What are the things that are required for merging? The things that are required for merging is this. You must know the array. So you must have the array. You must know the minimum. You must know the middle value, and you must know the maximum value. So you must know all these things. So let us give all this as the argument. So this is my array, original array. Then I have the minimum. Then I have the middle value. Then I have the maximum value. So I have all these things. So let us take the temporary array. I'm going to take an array. Let me take int temporary of 25. So I'm going to just take a temporary array. Remember that temporary array is required for us to arrange them or to merge them. So I need a temporary array. I'm going to call it as T so that you can reduce typing. I need the for loop for doing all these things. So I'm going to take the for loop ijk. I will take 3 for loops for achieving this one. So I'm going to take this. The reason why I have taken the 3 for loop, I'm going to explain it just a bit. So first for loop, I will be using it for one of the array. So for parsing all the elements of one first array, I'm going to use the I. Then to parse a second, I'm going to use the j. And you have this temporary array. To put the element at a proper location within this temporary, I'm going to use the counter k. So there will be 3 for loop. One is for the first array, second one is for the second array, and the third one will be for the temporary array that you are going to create. So let's go ahead and let's do that part. So what is the first array? From where will you start the first array? You know very well. This will be the minimum. Let me just keep it here. Not this one, sorry. Yeah, let me just keep it here. So this is the minimum, or so because it is. Let me just make them slightly here. Okay, now I think I'll be able to move it because it is coming to the border here. So this is the minimum, and this is the maximum. Okay, and there will be a middle value here. Okay, so these things will be here. So minimum and maximum and middle value. So let's start from this array. Suppose if you just take the whole array like this one. So let's take, this is the array, this is the middle value, and this is the maximum value. I've just done it because so that you can see few elements there. So first part is from here to here. So this one is from here to here. Okay. So I will start from the minimum value. So wherever the minimum is pointing, I will start from here. What about the j value? J is this secondary partition. Second one will start from the one more than the middle value. Remember, middle value is the last part. So one more than the middle value. What is middle is pointing to? Let me just make it. Middle is pointing to 2 here. Middle is pointing to 2 here. Plus 1, 2 plus 1 will be 3. So j will be pointing here. Okay, so that is done. What about the k? So what is this? A k, whenever I want to, let me pull them out. So this will be the minimum, okay, for the first element. So I will start from this value, minimum value. J will start from, let me just put it here. J will start from this value, that is 3. Okay, and in order to sort them, I need a temporary array, so that let me just pull them out. So in order to sort them, I need the temporary array. So the temporary array you generally will start from the minimum value. Okay, you can take it any value, but generally you start from 0. You can just take it as 0, then you can just transfer them back. But I'm going to take this temporary value, that is k, for this array. The counter is k, so this k will start from the minimum. Okay, so 0, 1, 2, 3, 4, and so on. So let me write that thing. So I will start from the minimum. Okay, j will start from mid plus 1. Okay, and k will start from the minimum. Okay, so this is done. So I will start from minimum. J will start from mid plus 1. Remember, mid was here. I just moved the mid here. Mid was here. Up to here is one partition. Mid was here. Mid plus 1 will be this value. Okay. And k, you know, variable is the minimum value. You start from doing it. Now let's start parsing both the arrays. So I will have to start from I is equal to minimum. Okay. And I have to go up to the mid value. Up to this mid value I have to go. So I will start from minimum. So this is one partition. So I will start from minimum, next up to mid. So this is one loop. So I'm going to just write a while loop here. So while I less than or equal to mid value, this is one thing that I'm going to do it. And there is a second array. So second array, you know very well, second array is given by the counter j, and j will start mid plus 1. So mid plus 1, mid is 2 now, mid plus 1 is 3, up to what is the last point, up to the maximum. So where is this thing? Up to the maximum. What is the value of a maximum? So maximum will be pointing here. So from mid plus 1, so mid is now pointing to, again, always concentrate on the indices, not the original. I'm not interested in the values here. I'm interested in the indices. So mid plus 1. So mid plus 1 will be 3 up to maximum. So this is what I'm going to write it. So I'm going to say j is already mid plus 1. J is already initialized. J is equal to, not this minus, j is equal to mid plus 1. This is already done. Then j must be less than or equal to maximum. So you have to go up to that point. So this while loop will continue here. In other words, what I'm doing is I am taking this I value and I am parsing all the element of the first array. In the same way, I am taking the j value and I am parsing all the elements of the second array. So I take one element of the array, okay, and among them I try to find which one is the minimum. Whichever is the minimum, I transfer it here. Okay. Now, because this array is splitted again further, so I'm going to just bring it down, because there, in this case, if you notice, minimum is less than maximum. You can still split it here. So I'm going to say minimum and maximum. Let me just bring it here, maximum, because there are two elements are there. This you can further split it. So let me split it again, and I'm now going to say that this is one piece, because you know very well you can split this into two halves. In this case, minimum for the first part, minimum and maximum are pointing to the same element, that is the a of 0. So in this case, this is violation, you stop the merger. Again, in the same using the same logic, what I can say is here also minimum is pointing to index 1 and maximum is also pointing to index 1. So it is not possible for us to split it further. So what we are going to do is I'm going to take the variable I here. So I is equal to 0. Okay. There are no more elements are there. J is equal to 1. Okay, so j is equal to 1 because this is one element. Now you have to add them properly. So in this case, you know that they are already sorted. First element is 5, the second element is 9, so they are already sorted, so there is no problem. What about this case? This is only one element, you can't split it any further. So now you notice that this array is sub-array is sorted. This sub-array is also sorted. Now again go back to this step. So how do you go back to this step? Start from I is equal to 0 and take the value. What is there at I is equal to 0? 5. Again j is equal to 2. What is the value at the j is equal to 2? 4. So among them, which is the smaller one? Whichever is the smaller one, you take, let me write the temporary array. Let me assume that this is a temporary array. You write this element first and then this element. Okay, so 4 must come first and then 5 must come next. So this is what you are supposed to do. So you are supposed to compare the element at a of I. So when I is equal to 0, a of I is this 5 with a of g. Okay, so whichever is smaller, you transfer them to the temporary array. So let's write that particular step here. So what I'm going to do now is if okay, a of I is smaller than a of j, that means if the first element is smaller, whichever is smaller, you transfer that to the temporary array. So transfer it to the k. Remember, I'm using that. So transfer a of I to that. So if a of I is smaller, so if you have this array, two arrays over here. Okay, if you find this is the I value, if you find a of I is smaller, then transfer that thing to the a of k. Okay, so transfer it to the a of k. Otherwise, transfer the k to the so transfer a of j to the kth element. So what is this I have written is again you have two arrays. One is a of I array is there, then other element is j is there. Now you just check whether a of I is smaller than a of j. So let's say this is 5 and this is 4. Now you notice that a of j, let's assume that this is the array a of j is smaller than a of I. In that case, transfer the element 4. So transfer this element 4 to the a of k. So if a of I is smaller than a of j, if the first element is smaller, you transfer the first element. If not, transfer the element of the second array. In both the cases, once this element is transferred, move the I. Suppose if j is so j is already taken from here, so j is over. Move the j to next position. Okay. Similarly, move the k was pointing here. Move the k to the next position. So the next element, whichever element is there, next element must come here. So once you have transferred an element to the array, move the pointer of that array to the next element. So 5 is transferred, that means you transfer it here. So let me just tell you how this is going. Now let's start from this one. So I is equal to 0. So I is equal to 0 means a of 0 is 5. J is equal to 0. So you've done that. You compare now. You compare the element. So which is smaller? A of this j equal to 2. Let me make that j equal to 2. This is the value. So you compare the a of I, which is a of 0. That is the element 5 with the element a of j. Okay, that is 4. Which is smaller? This one. So you bring this. This was I'm going to take it as k here. So let's take this k. So k was initially 0. You transfer that k value here. Done. Now the k has to be, k was pointing here, k of 0. And now k has to be moved to the next position. So in other words, you have to make k equal to 1. Whichever element that is going to come will come to the key of 1. It will come to this location. So increment the k by 1. Once the transfer is done, increment this pointer by 1. If you transferred this one, increment its pointer. Suppose if you transferred this one, this element, increment the counter by 1. How can I write that? So once the transfer is done, increment it. Okay. Similarly, once the transfer is done, if you're transferring I, increment it. If you're once the transfer is done, increment the k. If you're transferring the j value, increment it. So that what do I mean to say is once you have transferred an element, increase the counter value by 1. So I is equal to I plus plus. So I becomes a 1 now. So I becomes a 1 so that you get the next element. Naturally, k has to be incremented. Next, so k plus plus will make it k equal to 2. So whatever element that is going to come, the next will come to this position. So k is equal to 2. So increase whichever element you are transferring, increase them by 1. So that is what you are going to do it. Okay, this is done. So when you are doing it, there is generally one problem will come. So what is the problem? If you just look at here, if you just look at here, so I'm going to bring it back. Just let me remove this one also. Okay, if you just look at this array, so you compare a of 0 with the a of 2, which is the smaller. 4 is smaller. You transfer this 4 here. Okay, increase. You transfer 4 to a of k. So you transfer a of j to a of k. That is temporary of k. Increase this by 1. So what is the meaning of saying increase j plus plus? J will become 3. Okay. But you notice over here, this j has exceeded the maximum value. So it has exceeded the maximum value. It is over. There is no more elements are there. So when this thing happens, when j exceeds the maximum value, this while loop will break. So you are going to simply come out of the while loop. Okay. So what is going to happen now is when you transfer this element 4 here, this while loop, that while loop which was there will break. But what about these two elements? They are still there. So what you have to do? So these are, there is nothing to be compared because this array is shorter, this array is over, but there is one other array which was longer, it is still there. Okay. So what is going to happen in this case? Whatever that is remaining, Okay, you can't compare it with the other array because the other array is over. So whatever that is remaining, you simply transfer them back to the original array. So whatever that is remaining. So in this case, what you notice, I value has not increased. I is still less than the middle value. So this was the mid value. I less than the mid value. It's still there. So I value is not yet incremented. So you transfer I equal to 0 here. That is 5 here. Then I plus plus, you transfer this 9 here. So in other words, whatever remaining, either this array or the other array, whichever elements are remaining, you just transfer them back because there is no comparison that need to be done here because the second array is over. So when you are doing it, if you find that one of the array is shorter, then whichever elements are remaining, you simply transfer them back to the original array because there is no comparison that you can do it over here. So in this case, what you notice is once this 4 is transferred here, okay, there is no more element left in the second array for comparison. In that case, you simply transfer them back to the temporary array. So how do I write that thing? So if let me go over here. Let me start with here. So if there are any element left over, so while the value of I is less than middle, that means if there are any values that are left over, then transfer them back to the array. How do you transfer them back? K plus plus, you know very well, increase the k by 1, increase the I by 1. So how do you transfer these element? So first one, you transfer I is equal to 0 to the k is equal to 1 location, let's say. Okay, then increase the I by 1. I plus plus will make 0 plus 1 is 1. Okay, k plus plus will make k is equal to 2. So what is there at I of 1? At I of 1, 9 is there. Transfer that to the k of 2. So this location, so transfer it to there. Okay, so once you transfer it, increase the value of k by 1 and I by next. So you keep on doing like that. Similarly, if this is for the first array, if the first array is longer, you transfer it. Suppose if the second array is longer, suppose if you have a situation, just for explanation purpose, if you have a situation like this, the second array is now longer. In that case, move all the second whichever values that are left over directly to the temporary array. If the second array is longer, transfer all the elements of the second array directly to the temporary location. So how do I write that thing? Same story here. In the first case, if I value was less than middle, then whatever remaining value, you just transfer them to the temporary array. In the same way, if while j is less than or equal to middle, that means if that is the maximum, in that case, transfer the remaining element of j to the k. So this is what you are going to do. So the remaining element of j is transferred to the temporary thing. So once this transfer is done, remember this is the temporary array. Now transfer the individual element back to the original array. So this is one extra step. So from the temporary, write it back to the original array. So how do I write it back? So I'm going to use a for loop. For I is equal to minimum I less than or equal to maximum I plus plus. Transfer all the elements back to the original array. A of I is equal to temp of I. So that is it. What is the meaning of this? Is where is it? A of I is equal to temp of I. So this you transfer it back. A of I you transfer temp of I. A of I you transfer temp of I. So in other words, you transfer the first element to the first location from the temporary to the A array. Okay. Second, you transfer the second element to the original array. So you take it and transfer it there. Let me do it. Okay, and you take the third element and transfer it. In other words, individual elements from the temporary array transfer them back to the original array. So that is what you have done. So this, if you keep on doing it, and now you have done this one. Again, take these two sets, sort them back to the original array. Again, take this two set, sort them back to the original array. So you keep on doing like this until this is done. So this is the recursive call that you will have to perform. So let's write the first part here. What was the first part that we have not written is how do you split them? So given array which was here, you have to find the middle value. You have to find the middle value. How do you find the middle value? So I'm going to write a function for that because that function will be called recursively. So I'm going to say merge sort. I will call it as M sort, and I'm going to pass the original array to this one. I will pass what is the minimum value and what is the maximum value because I need to find the, let me just press a few enter sign and make it visible here. So I have to find the middle value. Let me say int middle. So find the middle value. How do you find the middle value? Remember, you will find the middle value only if there is at least two elements. So in this case, you notice that minimum is not smaller than maximum. There is no point of finding mid value. Mid values are found only when you have a minimum value which is smaller than maximum value. In that case only you try to find the mid value. Okay, so let's write that story over here. So if minimum is smaller than maximum, then only you will do the uh, sorting as splitting as such. So you are going to say find the mid. How do you find the mid? Minimum plus maximum divided by 2. You know how to find the middle. Middle of minimum and maximum is half of it. Then you will split the array. So you find the mid value. You find the mid value. You split the array into two subset. One is the first subset from minimum to the middle value is one subset. From middle plus 1, remember this middle value is up to 4. Let me just show it here because I'm not interested in the actual values here. I'm interested only in the index value. So from the minimum to the mid is one set, and mid plus 1. So that is the next. What is the value of a mid now? Mid value is 4. 4 plus 1 will be 5. So mid plus 1 to the maximum is the second array. So again, this has to be recursively splitted into half. So we will call the same function again, and we are going to pass that thing to there. So what is the name of this function, which is giving us the middle value? So the name of this function is msort. So I'm going to call this msort again. So this is the recursive call, and I'm going to find, I will pass the array A, and I will pass the minimum value, and I will pass the mid value. So minimum to the mid. So this minimum to mid is one value. So that's, so minimum to mid is one array, and mid plus 1 to the maximum is the second array. So how do you say that? M sort mid, pass the same array, mid plus 1 up to maximum is the next array. So that is done. Okay, so you keep on doing it. So you keep on doing this. So you start from here, you split it into half. Again, you take this array, you split it into half. Okay, you take this array, you split it into half. You keep on doing it until you find that no more elements, so you cannot split it any further. So when you can't split it any further, merge them back. So you keep on dividing the array, first array, into smaller, 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 so smaller, smaller subunit until you get only one element. When you get only one element, merge them. So finally, you will call this function, which is this function, merge function. That's going to merge them in the ascending order. So I'm going to call that function. So let me call the merge. Finally, you are going to call this merge function, and I'm going to pass minimum, mid, and maximum. Remember, for the merge function, we are passing three parameters: minimum, maximum, and minimum, mid, and the maximum. So this is there are two functions. So the first function will split the given array into smaller unit. This one will keep on splitting the array into smaller and a smaller subunit until you find that it is not possible to split them back in any further. Once that scenario is achieved, you will merge them back in the ascending order back to the original array. So finally, you're going to merge them back to the original array. Again, finally, you will merge these two back to the original array, and finally these two you are going to merge it, and you will keep on doing like that until the entire array is sorted. So that's only logic which is there in this thing. So let's write the main function, and let me assume that I have an array of 25 elements. For the examination, you may not go beyond 5, but just 25 I will take it. And when you talk about array, we will not use all the 25 elements. We will use the n elements. Generally, n is 5 or 6 during the examination. And for a for loop, I need a counter variable, that is I. So the first thing that I'm going to ask is, what is the, even though I have 25 elements, I will ask what is the total number of element, which is generally smaller than that. So I'm going to say enter total number of elements. I will put one space here. I'm going to use the scanf function, and I'm going to read this one here. Okay, done. Then I'm going to use one more printf element. So if the n value is 5, I'm going to say enter 5 elements into the array. So I'm going to say enter %d, that enter 5 elements into the array. Okay, so that is done. But that n will be this. So whatever n is there, so if n is 5, you will say enter 5 elements into the array. If n is 10, enter 10 elements into the array. But during the examination, I don't think so. You will write more than 5 elements. But so let's start with the inputting the elements. So remember, during the examination, if you don't know anything, you can write this part. This is common whenever you are writing any array related functions or any array related program. This is the general step that you are writing. So you first ask what is the size of the array, and then you enter the elements into the array. So this is the most general thing. So write this one, even if you don't know anything, write this one. You will be given some appreciation mark. Again, I am not guaranteeing that you will be given a, what is this? You will be given a pass mark. So you may not get the pass mark, but you will be given some appreciation mark. Okay. That appreciation marks itself may add, and you may get a pass mark. Okay. So that can also happen. Let me remove this closing bracket over here. So you use the scanf function to read all the elements into the array. Done. Then I'm going to call this function. This is a function that is going to split the array into smaller subset, and it's going to call the merge the other function. So it will automatically call. So I'm going to call that function. So I'm going to say msort, and I will pass the array for the first element. For the first array, what is the minimum? Minimum is 0. What is the maximum? Maximum is, if this is en, this is en minus 1. You know very well, because we are starting from 0. This will be n minus 1. So I will start from 0, and I will go up to n minus 1. This will sort the given array. After this, okay, I'm going to print the sorted element. So I'm going to say sorted elements are, okay, and I'm going to print them. Again, I'm going to use a for loop for this. Again, is a common step that is there. So during the examination, write this part also. Again, you will be given some appreciation mark, and that may not be the pass mark, but you will get an appreciation mark. even for writing this much. Okay, so write, don't forget to write this one. So this part, always remember, this part is common for most of the sorting array. So this part is common for almost all sorting algorithms. So that is common. So whenever somebody says sorting, you create one array and you input the values into the array and print the values. The in between part you may not be knowing. This may be quick sort, this may be merge, the insert sort, or any other type of sort which you have, that you write it on your own. Okay, so let's save this one. I hope I have not done any mistakes. So let me run it, and when you run it, if you get this kind of thing over here and you don't know what is the problem, you just go to view and you go to the logs, and it's going to tell you that you made a mess here by putting a dot here. And let me run it again, and this is what you have. Let me enter 5 elements into the array. So I'm going to say 10, 0, 20, -4, 5. So let me press enter, and you get all the elements, no doubt, but only mistake, everything is proper, but it's a good thing that I did this mistake. So if you don't put the spaces after this printf, where is the main, where is the printf statement? You don't put the spaces here, all the numbers will come closer to one another. So when you are printing it, put one extra space here. So put a space here so that numbers won't touch each other. Otherwise, you see that all the numbers will touch one another and you won't figure out what is going on. Let me run it one more time. So 5, let me start anything, 20, -5, 4, 0, 2. Enter here. So you notice that -5 is the first element. So this is sorted. So this is the sorted element that you have. That's all in this exercise. Thank you for your interest. We will meet again in the other exercise. Thank you.